Good morning. We already start the second chapter from F.Y.B.Sc class, and the paper is CH 102, that is paper second, organic chemistry. The chapter second is Aliphatic hydrocarbon. And from this second point is alkene. Alkene is the hydrocarbon which having carbon-carbon double bond, and the general formula is CnH2n. Now we will see here, by putting the value of n, and we discuss about the homologous series of the alkene family. Now suppose here n equals to 1, then formula become C1 and H2. But here it is not possible to form the alkene first member here, so it is discarded. Then n equals to 2, then C2H4, and the structure of this compound is C2H4, and the name of this compound is ethylene. Okay, then n equals to 3, it becomes C3 and H6, and we obtain the next structure CH3 CH double bond CH2, and this is propylene. And when n equals to 4, C4 H8, and here CH3 CH2 CH double bond CH2, and here it is butylene. And we will see one more example where n equals to 5, C5 H10, and here CH3 CH2 by 2 CH double bond CH2, and the compound is pentine. Now here, when we move from first member to higher member here, each time CH2 is added, and one more thing is here, when we see the higher members, means above the n equals to 4, the isomerism is also increases. So we will see some isomers of butylene compound So next point is isomerism. Next point is isomerism. So isomerism in butylene compound, where formula is C4H8. Here first of all we will see the positional isomerism, means the position of double bond is present at different places. So CH3, CH2, CH double bond, CH2, and this is one butylene, and suppose this double bond is present in between second and third, then this is 2 butylene. Means this is the example of positional isomerism, where here double bond is present in between first and second carbon atom, and here in between second and third carbon atom. Also there are one more type of isomerism is geometrical isomerism. Geometrical isomerism. Again take the example from 2 butylene. Here this carbon atom is sp2 hybridized, and hence the geometry is a trigonal planar, and hence here we consider the plane of carbon-carbon double bond, and when same groups are present on the same side of this plane, then this is called as cis 2 butylene, and when these C3 groups are present on the opposite side, then this is termed as trans 2 butylene. Means when we move from lower member to higher member, here the chances of isomerism is increases as compared to alkane. Okay, now we will move towards the nomenclature. Now there are two systems of nomenclature: common names. In common names there are the suffix LENE is put here: ethylene, butylene, and propylene. But this common name system is limit for lower members, and there are one more developed method is IUPAC nomenclature system. Last video already discussed about the rules as well as steps of IUPAC nomenclature system. Now you know very well about this. IUPAC, and here rules. First of all, the finding the longest carbon chain containing carbon-carbon double bond. Then second, numbering. The condition is that the carbon-carbon double bond having the least number. Then third one, substitute generally alkyl group. And last one, suppose there are cis or trans isomerism, we mention the cis and trans isomerism. Now we will take example here, some examples for this. Now in this case, when we go through these rules, the first is the longest carbon chain containing carbon-carbon double bond. Now in this case there are no problem because this is a straight chain and there are no branching. But in second, when we consider the numbering, there are two ways to use the numbering here: 1, 2, 3, 4 and 5, and another way 1, 2, 3, 4, 5. But in this case we already mentioned here least number is for the carbon double bond, but in case of second one here there are third number is come from the carbon double bond, so this is wrong numbering, so we discard this one, so this is the correct numbering. And then substitution. In this case also there are no substitution. Then here actually find out the parent alkane. Now here there are 5 carbon atoms, so this is pent and double bond is present, so pentene. Suffix is here pentene, and double bond is present after 2, so here 2 pentene. Now in this case this is suffix and this is root. Now we will see one more example here. Okay. Now in this case there are 2 branches, 1 branches and 2 carbon chain, but this is longest carbon chain. Then as per the second rule, numbering 1, 2, 3, 4 and 5. So, and 5 carbon atoms, so root is pent, suffix is eni, 3 is the 3 showing the position of carbon carbon double bond, and we also mention the alkyl group. So this is the 2-methyl 3-pentene. In this case, this is root, this one is suffix, and this one is prefix. I will take one more example here. Now numbering here 1, 2, 3, 4 because Br is attached here. So 1 bromo, 2, 1, 2, 3, 4, so it is butene. One more example we take from the some higher member. So here this is the longest chain having the carbon carbon double bond. Then numbering 1, 2, 3 and 4. So here BUT is the root, butene, double bond is present in between first and second carbon atom, and there are 2 methyl groups are attached, so 3 dimethyl, 3 dimethyl butane. So this one is root, this one is suffix, this is prefix. We take one more example from the cis and trans. So here 1, 2, 3, 4 and same groups are present on the same side, so it is cis 2 butene, and here this is trans 2 butene. Now these are the IUPAC nomenclatures. After this we will move towards the preparation of alkene. There are various methods we observed here, but common method is that it should be prepared by the elimination method. or with the help of elimination reaction. First method, by cracking of alkane. Now in this case, when alkane, suppose you take the example here, ethane is subjected to cracking at 450 degrees Celsius to 700 degrees Celsius. Here H2 molecule is removed and we obtain ethene. Now second, dehydrohalogenation of alkyl halides. We take general reaction here. This is alkyl halide. In presence of KOH and ethyl alcohol, means here this OH is considered as base, and what happened, this Br and this CH is removed in the form of BH plus Br minus, and we obtain alkene molecule. Now we take some example here. We take 2-bromo-propane as a starting material, plus KOH, ETOH, and temperature. Here Br and H is removed in the form of KBr plus H2O, and here CH3, CH double bond CH2, means 1 propene is obtained. Now here this molecule is symmetrical molecule, but when we consider the unsymmetrical molecule here, we obtain the mixture of alkenes. Now we will see such example here. Now here this Br is attached to this carbon atom, so this is alpha carbon atom, and here this is beta carbon atom, this is also beta carbon atom, but this is one is, we can say that beta dash. Now here this reaction takes place in presence of KOH and ethyl alcohol and heat. Now this is not a symmetrical molecule, this is unsymmetrical molecule. Okay, 2 bromobutane. Okay, now suppose here this Br and beta hydrogen is removed, then we obtain CH3CH double bond CH3. We obtain 2-butene plus here Br and beta dash is removed, then we obtain 1-butene. But here this having 81% is the yield and this having only 19% is the yield, means yield is major yield here and here minor yield is here, means here 2-butene is the major product and 1-butene is the minor product, and each time more substituted product having the higher yield or major yield, and this is explained by the scientist Shelke, and hence this rule is called as Shelke rule. What happened in this case? The statement of this Shelke rule is in an elimination reaction, the highly substituted alkene is the major product, and this is considered as this is called as Shelke rule. Means it can be said that more substituted alkene is the product is more stable and it form faster. Okay, we will see the second example here, the second method, that is dehydration. Dehydration of alcohol. General reaction. Now this reaction takes place in presence of acid and heat. Whatever here, this H2 molecule is removed from here. That's why it is called as dehydration, and it forms the alkene. We take some example. Suppose 2-butanol. acid, and we obtain the major product. Again here Sedgwick rule is follow. CH3, CH double bond, CH and CH3. This is the 2-butene. 1, 2, 3, 4. 2-butene, and this is major one. And last example, tertiary butyl alcohol. Now here 20% H2SO4 and heat, and it gives 2-methyl, that is 1, 2, 3, 2-methyl, 1-propene, or common name of this compound is isobutene. So today we see the preparation as well as a preparation of this alkene. Okay, thank you.